we will talk about two types of muscle fiber. When you eat chicken, you pay attention that the meat from the chicken breast is different from the meat from chicken leg. They are slightly different, they look different and even taste different. So, the same in humans, we have two types of muscles, red muscles and white muscles. If you go to YouTube, you'll find that video easy. It's called Easy Illustration on Muscle Fiber Types. You can stop this video right now, go and watch a YouTube video, and it will help you to understand the concept. So muscles are classified according to two characteristics: speed of contraction. Muscles can contract slow or fast. It depends on what type of signals, electrical activity, they receive through the motor neurons. And it depends on metabolic pathways for ATP synthesis, what exactly those two types of muscles use to produce energy. Oxidative fibers use both glucose and oxygen, that is aerobic pathways, using oxygen. And glycolytic fibers use anaerobic glycolysis. They just use glucose without oxygen. So two types of muscle fibers, muscle cells. And most of our skeletal muscles, inside of them have all three types of muscle fibers, but always one of them will be dominant. Some muscles have more or of oxidative, slow oxidative fibers, others have more of fast glycolytic fibers. Some books will tell you that there is a third type, fast oxidative fibers. It's like a mixture, it's in between type 1 and type 3, but we will skip it in this class. Just know there are two types, slow oxidative fibers. They contract slow and they use oxygen to make ATP, and those would be red fibers. In chicken, those would be in chicken legs. Second type, fast glycolytic fibers. They contract fast and they use anaerobic glycolysis using glucose without oxygen. The contraction is strong, but they fatigue quickly. In chickens, that would be white fibers, that would be breast muscles. Here is another table that will help you to memorize the difference. Type 1 and type 2, these two types. So red muscles, high efficient. They produce contraction for a long time. They are efficient. They are smaller in size. They have a lot of mitochondria. They are resistant to fatigue. The force is not so strong and speed of contraction is low. That's what you need to know. White muscles, they have a low efficiency. They cannot last long, but the contraction, speed of contraction is high, force produced by them is high, and size, they are large. But fatigue resistance is low and mitochondrial content is low. Influence of load. The greater the load that we lift, for example, the longer is the latent period and the weaker is the contraction force, and the slower and shorter the duration of contraction. For example, if you have to hold something for a long time, definitely you can hold a book for much longer than you can hold a heavy chair, for example. Effect of exercise. Two types of exercise, aerobic and anaerobic. Aerobic exercise, or exercise for endurance like running, causes our muscles to develop new muscle capillaries. Number of mitochondria increases, and protein myoglobin that carries oxygen, its synthesis increases too. Muscles become stronger and resistant to fatigue. Sometimes glycolytic fibers can even be converted to oxidative fibers. Now resistance, anaerobic exercise, like weightlifting. That causes muscles to increase in size, increases amount of mitochondria and glycogen store. Pay attention. Muscles increase in size, but amount of muscle cells or muscle fibers doesn't change. It's just amount of myofibrils inside of them will increase. So muscle cells become larger, but their amount stays the same. Atrophy is a decrease in a muscle size. There can be different situations that can cause it, and first would be lack of protein in nutrition. Muscles cannot rebuild themselves and they shrink. More common nowadays would be a decrease due to inactivity of the muscle. Let's say somebody broke an arm or leg and they cannot walk for 2 or even 3 months. Then their muscles in that leg will shrink.